Hello, everyone. Wow, it's been an absolutely great day of discussion and learning here in the API Management and Gateways track. I'm your host for the track, Brian Wilson. Please remember, at the end of the session, we will be starting office hours, and also make sure that you ask us questions. Put your questions in chat. It's being monitored. We'll get you answers. And if for some reason you don't get your question answered, the question's harder to ask than just typing it in, again, join us for those office hours. The speakers will be there, answer your questions, talk about topics, whatever. So with that, let's just get started with our session from Chris and Simon. Over to you guys.
Thank you, Brian. So, hi everyone, this is why you should own an internal platform for your external AI and SaaS providers. Before we begin, let me introduce myself. I'm Chris Phillips. I'm an IBM SDSM. I'm very experienced at IBM API Connect. I've been around the world talking with clients about how they use an API Connect, sorting out their problems as the chief architect for the SWAT team. I've been in integration for 15 years and 17 years in IBM. Simon, you'd like to introduce yourself quickly?
Sure, my name is Simon Capadi. I'm the API Connect security architect. Whenever I introduce myself, I just say I'm the security guy because that's what I've been for a long time, over a quarter of a century in IBM, working for a long time in services and then going through various development organizations to now take on the security architect role for the API Connect product.
Great, thanks, Simon. And Simon and I have worked together on and off for the best part of a decade now. So we've sit down and we often come up with conversations. And he may not remember, but this slide deck originally came from a conversation we had a couple of years ago of going, why wouldn't you do that? And this is sort of supposed to be very much more of a theory. This is not a look, this is what the product can do, because yes, the product can do this, but it's trying to think of things in a slightly different way and how we're starting to see more and more use cases are coming out, and we want to make sure and capture this and sort of show off what can be done today with the capabilities that we have in the product now. So let's set the scene. Fair to understand me, I'm assuming here everyone has some form of enterprise application, given the audience we're at. There's an application that they are running, they are looking after. And that's got to make a call to some form of external service. Now that could be an AI cloud, it could be a SaaS service, it could be any external service. But the critical thing for this example, it is something outside of their business. So that the enterprise application is making a call and to an external service, whether SaaS, whether AI. And this is a fairly common model, and it's fairly easy to envisage this. But now let's take a step back and go, well, realistically, there are many options here. It's not just generic SaaS. We are talking, it could be Salesforce, it could be ServiceNow, it could be What's Next, it could be ChatGPT. But what's more is it's never one application anymore. There are thousands or hundreds of applications organizations have calling to these set of external services. And this could mean that this enterprise application here has a contract with Salesforce, and this enterprise application has a separate contract with Salesforce. And this enterprise application here doesn't actually have a contract with a generic SaaS provider. They just found a trial key lying around somewhere that they're using and they're liable for. And maybe they'll start to look at what's next. And this team has got their own contract with what's next. And there's other teams going to come on board who would benefit from learning from their experiences. So what we're talking about here, and finally, in this day and age, with the intelligent SaaS systems that we have today, maybe one SaaS system is going to talk to another SaaS system on your behalf. Maybe you have a system set up such that Salesforce, whenever a request comes in, will go somewhere else and create a customer record in a different CRM database, because your solution and your way of using these SaaS services to make them work together, so you can quickly and easily and powerfully, without interrupting yourself, get these two systems to play nice. But how do you track it? How do you understand? How do you detect when malicious or bad actors occur or invalid requests occur? And that's what we're going to talk to you today. about how an API platform will be able to help manage and control this better. So the idea here is we can take our external services, we can expose them as internal APIs. Now, this is the same as we've been saying for a long time of taking your internal systems and expose them as external APIs. But we're flipping this on the head here. We're saying we can make use of the same capabilities that you use to expose to your external consumers or internal consumers today. But now we can use those same benefits to help protect your internal applications, your internal consumers. And if Salesforce wants to talk to the generic SaaS service, it can reuse the same API and be treated just like another internal application. Okay, going through an external route, but have the same benefits associated to it. So the key topics we're going to cover today are security and control, accountability, protection, and simplified migration. These are the key pillars that I see and the benefits that you can get from doing this. So I'm going to hand over to Mr. Kapadia here now.
Thank you, Chris. So control and security, this is obviously where I come in. Let's take a scenario here. We've got two enterprise applications internally, and they're contacting the same generic SaaS provider who's somewhere out on the cloud. And again, we're talking generic terms here. So let's assume that both of these enterprise applications use a form of authentication to that SaaS provider that has been, negotiated. So someone in your organization has, signed a contract with the SaaS provider. So they've said, here's your API key. This is how you access this service. So that's all good. Each enterprise application gets a copy of the API key. Whenever they make the calls to the generic SaaS service, they send the API key, and that's how they authenticate to it. What happens when that API key is compromised? Let's say that enterprise application 2, the developers who write the CI/CD pipeline for that enterprise application accidentally include that API key in in a GitHub commit. And then instantly, of course, they delete that commit because they think, oh God, we shouldn't have done that. But it's stored in the history of that commit, because that's how change control systems work. And an attacker looking at that commit history could pull out that API key and use it and connect as that enterprise application. So that key is considered compromised. Now, of course, you'll have mechanisms to detect that kind of thing, and the developers of the enterprise application will have been, will receive eventually some kind of a warning saying, you've done this wrong and this is compromised, and you have to stop using this API key and reset it. So what happens when you do that? The API key is reset, and both the enterprise application that made the mistake and enterprise application 1, which was doing its own thing and didn't make any mistakes at all, is completely separate and isolated. Both of them stop working. Both of them need to be updated with that updated API key. So both applications are impacted, even though only one of them actually made a mistake. So if we can switch to the next slide, please, Chris. So let's take a look in a little bit more depth as to, a more realistic scenario, because that's just like a small, beginning example. So what this may look like in the real world, as Chris said, these things proliferate. So you may have multiple services that you're calling, and each of those services might have its own credentials. In this example here, we actually are presenting a single SaaS API, which is being serviced on 2 different SaaS providers. So maybe your API platform is saying that, some requests that come in get sent over to that API, generic SaaS provider 1, other requests go to generic SaaS provider 2. The API platform is presenting an internal generic SaaS API to its enterprise applications. It's hiding the fact that there are, potentially multiple implementations out there in the cloud. On the left-hand side, we see that there are multiple enterprise applications which are calling this API, and they're all using their own credentials. In fact, in this environment, they're using their own form of credentials. So enterprise application 1 might be, I don't know, let's say it's a Java application, and the way that it manages to authenticate to call the API is it uses a client's X509 digital certificate, which is sent as part of the SSL handshake in a mutually authenticated SSL session. Enterprise Application 2 is using an API key, but you'll notice it's not the same as either of the API keys on the right-hand side. It's a different API key because this represents a trust relationship between Enterprise Application 2 and the API platform. And the third API Enterprise Application here is using an OAuth token. And again, this is, we can go down into this into a very low level of detail, but let's just say it's another form of authentication, and it's another contract between the enterprise application and the API platform. So Chris, if you press the next slide button, the points I'm making here is that each enterprise application has their own credentials, and those credentials are going to be appropriate to the technology that the enterprise application uses, to the capabilities that, these could be implemented on different platforms in different software. And each of them has their own credential. And if you press the next button again for me, Chris, on the right-hand side, the integration platform has the appropriate credentials for the various SaaS platforms being called. It's mediating the credentials that it's receiving with the appropriate credentials to pass out to the external SaaS provider. Now, go ahead, Chris.
Simon. So Simon, just to reiterate one part of this in particular, we are allowing the enterprise applications to use the credentials that meets their need, not saying they must follow what is available from the SaaS provider. So we can do that credential mapping or credential conversion almost from one type of credential to another.
Absolutely, yes. And there's loads of benefits for doing this. I think we talk a little bit later in the presentation about some of the reasons for it. Yes, I think we do. So, but yes, absolutely. Okay, if you jump into the next slide, we will talk a little bit about a scenario, and this is a kind of what happens if scenario. So let's say we've got these two applications on the left-hand side from here, and we've got one application on the right-hand side, this generic SaaS provider that we're contacting. What happens if the API key that Enterprise Application 2 is using is compromised? Well, and if you click the next button, only Enterprise Application 2 is impacted. It can't talk to the generic SaaS API internal interface. The actual call to the outside world, the call to the generic SaaS provider isn't affected at all. Other applications going through the API platform aren't affected. It's only that enterprise application that is impacted. And Enterprise Application 1 doesn't even notice. And when we reset that API key, ZYXW, whatever it is, when we reset that API key, then that's a discussion between the enterprise application and the API platform, not with the external provider. Now, what happens if you click the next button for me, if the key that contacts the generic SaaS provider is compromised? What happens then? Well, when we reset that, both applications are going to be provided. If you click the next button for me, Chris, both applications are obviously going to be impacted, but their relationship with the API platform isn't affected. So there's only one place, if you hit the next button for me, only one place where we need to update that API key. The API platform is where the control of that relationship between your company represented by the API platform and the generic SaaS provider is being held. So you update it in that one location, and all of the enterprise applications that are calling it via the API platform can function correctly again. So I think, go on, Chris.
Sorry, and just to build on this, this means the API platform operator or team are responsible for that relationship for the API key to the generic SaaS service. So the Enterprise Application 1 and Enterprise Application 2 teams doesn't need any engineers assigned to make this change. And that split of responsibility.
Absolutely, yeah. So I think at this point I hand it back over to you, Chris, to talk a little bit about accountability.
Thank you, Simon. Sorry for the interrupts. So, real world, we have multiple enterprise applications, and it's hard to track what exactly each application is doing. It's easy here, we've got 4 on the screen, but imagine you now have your hundreds of applications making calls to various different services. Enterprise 1 can call everything, Enterprise 2, application 2 only does Salesforce, Enterprise application 3 only just generic, and so on. So being able to understand who is using what is critical. So having an identifier like a client identifier, you potentially could use an API key to help do some of this, to be able to point at, well, we know that the Salesforce APIs are being used by Enterprise Application 1 and Enterprise Application 2. Means that we know that if we need to decommission that or change that API, this is who is going to be impacted. Also, we can go that if we are paying for access to your generic SaaS service, then we can capture who is using what, which client ID is using what proportion of calls. So we can go through and be able to, as many clients talk to me about, but I've yet to see anyone actually implement this, cross-charge internally. So if we have, say, a large $10 per 100 calls to the generic SaaS service, we can work out how many calls has the Enterprise Application 1 made, how many calls has Enterprise Application 3 made, and ensure when they're looking at cross-charging internally, they can share out that revenue. What's more, you can understand the usage models here. You can now sort of say, well, we know across the business, we are going to be calling generic API service 10 messages per day, but next month we're predicting 20 messages per day, and you can start making better predictions for capacity management, understanding, and is there more we should be capturing, and is there more we should know? So that we enable the ability to have one contract between the API platform and the downstream services, the Salesforce, the generic SaaS, the What's Next, so you can get economies of scale. Each client has their calls directly calculated, allowing for exact internal billing. So there's no point saying, oh, you're both using it, you pay half the cost each. You can now say you're doing 95% of the traffic, you're using 95% of the tokens, they're using 5% of the tokens, and being able to show and then cross-charge correctly. And finally, we can detect unusual call patterns. If we suddenly see Enterprise Application 4 making 2,000 more requests a day to What's Next, maybe that's a conversation we should have with them to make sure they are aware of that change. Have they not warned us that they're going to be sending more traffic? It doesn't necessarily mean it's going to be a problem, but it gives you the avenue to go and understand exactly what is going on and highlight potential concerns quickly rather than just wait for the bill to come in. And let's say Enterprise Application 5 appears. If Enterprise Application 5 wants to start using the What's Next APIs, as the API platform owner, you could tell them, because it's all an internal clients here, where all the enterprise applications are the same customer's internal client, you could tell them, go and talk to the owners of Enterprise Application 4. These guys are already heavily using it. Maybe they could provide advice on using the API and how to handle it. And thus actually doing better community, better ecosystem management around your API platform, exposing these APIs. Because at the end of the day, the more self-sufficient your enterprise applications teams are, the easier it is for the API platform to manage and run with less tasks to support them. And now let's go on to the next topic we mentioned. What about Salesforce? So let's say Salesforce wanted to call ServiceNow. And they are sending data from Salesforce to ServiceNow. How do we detect things like someone's misconfigured something in Salesforce and it is sending sensitive data out? How do we detect that Salesforce is sending 10,000 messages a second into ServiceNow and creating hundreds of tickets when it should have been creating 1 or 2? Okay, yes, we could look at ServiceNow and see that, but which point did that start changing? Using the analytics capability inside of the API platform here, we can start getting an understanding of when changes of patterns occur, not just from our own application that we control inside, but we can also see if Salesforce is now leaking information it shouldn't do. Let's say someone has misconfigured Salesforce and it's sending confidential or restricted data through to another SaaS offering. That can now be analyzed and assessed from the analytics. And if need be, you could even do redacting of data inside of the API itself to ensure that the data you're sending through is of high, good, and secure quality. So the platform tracks what data has been shared between Salesforce and ServiceNow. We can again detect unexpected calls, and we can remove the need to store ServiceNow credentials directly in Salesforce. That's a point I did mention. So one of the concerns people have when I've spoken to a couple of SaaS providers at a couple of conferences last year, or one conference last year, and they said that they found challenges because some of their customers did not want to have their credentials for their SaaS platform stored in another SaaS platform. Not because they didn't trust it, but they didn't want to take the risk. And so by doing this, we can put the credentials is only going to be with your API platform, not your downstream ServiceNow. So you're only going to be able to have the exact level of access that you would want them to have, and then potentially giving a better, secure experience. And finally, as we started with this one, economies of scale. You don't need each enterprise application doesn't need its own contract with the external system. They can do this from one. They can do this with one contract between the API platform and the downstream service. And each client application can then have the internal contract, as it were, with the API platform. So I've got a video here now. Now, if you've seen some of the other sessions today, you will recognize this video. I have cropped it down just for the relevant part for today. But in here, we have the API Connect consumer catalog. And here we have a application with some credentials. So we're just going to grab those credentials and we're going to talk through what I've been talking about. So here we have a API testing tool. We're going to put in the client ID value in here, and you can see from the URL above, this is called an API Connect. And this is the payload we're passing in. So we're calling watsonx with the 13B Granite model, and we're sending the text in, and these are the token parameters we're sending in. So this goes through and it responds in just over a second with the response. And we can see that this is making a call on this URL, and this is the response we've got. So this is calling the watsonx system via going via an API platform. Now we can do, and one of the advantages which we're going to talk at the end, is we would do the same call again. Is it paused? And because we've cached the response inside the API platform, we can see this is now returning in sub 500 milliseconds. So the API platform allows you to also cache requests and responses, so you're not having to call the external system so frequently, reducing call volume. Now let's go and look at the analytics itself. So if we jump to the analytics here, in API Connect, we have a number of dashboards, and we've added an AI usage dashboard. But for those use cases that aren't AI based, any of the other dashboards are great. We're going to provide this level of information. The AI usage one is particularly interesting because we now can track AI tokens. Now, here you can see there's 4 consuming organizations using this. They've made 373 requests and they use 26,000 tokens. And here we can see on the graph that between the 6th of June and the 7th of June, these are the quantity of calls being made. So we can see how many tokens have done request and response tokens. And we can also display this as a heat map, so you can see which are the busiest days. Now, currently, this is just for the AI, external AI system, but you could have this for your external SaaS providers as well, and see which is the most important ones. And we can filter these per API. But you can here capture when are the busiest times of the day, so you understand when are you making the most calls on your external systems. If we jump to detailed usage here, and this is where the real magic is for accountability, we can see here that the HR team has used nearly 10.2 thousand service, payroll team has used 8,000 tokens, and the logistics team has used 7,000. And we can see how that's used over periods of time on the timescale on the left graph. So here we can instantly see through the given time that we have filtered to, who is responsible for using the external services. How and if there is any anomalies, we can put those out from these charts, or if there's changes, we can pick them out from these charts and show them clearly where things have changed, so people can be held accountable, or at least be questioned if things are unusual here. And here we can see the caching here as well. So that's from the accountability session. I'm now going to hand back over to Simon.
Thanks, Chris. So one of the things Chris was showing there in the demo was that we're calling this AI service, this what's next, which is it's an API fundamentally. This is a call to some service that's giving us data. In this instance, it's what's next AI. Now he was talking about tokens, and tokens is a mechanism by which you can calculate the cost of those calls. Because fundamentally, every call to a SaaS service or AI turns into something that resembles money. Everything costs money in this day and age. There's nothing that appears for free. There may be a very low level free tier of some service, and the reason that exists usually in a SaaS environment is to encourage people to start using it so that they can be charged for using it. And the typical way of charging is via calls, whether that's tokens or whether that's number of API calls for a typical API service. It usually turns into dollars. So think of a situation here like we have displayed on the screen, where we've got a couple of enterprise applications, and those enterprise applications are calling a generic SaaS provider. Now, the generic SaaS provider starts off with, if you click the next slide button, Chris, I think we had this down here. So it starts off with a free service, and it has a maximum budget of, say, $200 a day for calling the generic SaaS service. And anything over that is going to actually be billed. So it says, okay, we're typically saying your standard budget within the free service is $200 a day. We're giving you $200 value for free. That's how they would advertise it. That's how they'd market this service. But the moment you go over that, you go onto their next tier platform, which also is charging $1 per 1,000 API calls, but it charges you for all the 200 that you had in the free service, and then it charges you more. And as you go up in volume, the amount that you get charged increases. Now, on the left-hand side here, we've got a couple of enterprise applications, and we've set up limits on the API platforms to say this enterprise application 1 is making calls via the API platform to that generic SaaS service, and we want to make sure that it's not calling more than, say, 100 calls per hour. So we're setting this on it can be on a per API basis or on a per service basis. We're saying, okay, the limit that we want is only 100 calls per hour. Enterprise application 2, on the other hand, we're only allowing it to make 50 calls per hour. So this is something we can set by consumer, by the client that's actually calling in to the API platform. Okay, so that's our basic scene at the moment. Now, what happens if, as is very common in the real world, because remember, these enterprise applications, these are actual applications that are doing things themselves. They're probably serving real world traffic, and there's probably something out there that's calling them. This SaaS service is what we would used to call in the old days our back end. This is the same as the back end system that we used to call, and the enterprise application is being called itself by real world users. So let's say in this instance, our enterprise application 1 is an internet facing real world system, and it's serving up data for something that's internet users every now and again come and take a look at. It's providing a service to real world users. And if you click the next button, Chris, what happens if that application suddenly goes viral? Someone posts it to a tech news site, and everyone suddenly finds that this is interesting because the data that it's providing is showing things in a novel way. And this is what you want, isn't it? This, when you socialize your applications, your APIs, you want them to go viral. You want people to start using them. What happens when it goes viral and suddenly, instead of 100 calls per hour, you're getting 200,000 calls per day? Well, we don't want that to suddenly turn into a huge bill on your generic SaaS provider, because remember, the moment you go over your 200-day budget, which is however many API calls that is 200,000 calls, you're going to start getting charged, and that's something that you're not currently prepared for. So this is where we want the API platform to cut in and say, okay, that's now over the allocated budget. We want it to stop. If you click the next slide button, it'll come in and say, we don't want this to suddenly generate unexpected costs. And if you click the next slide button, the point that we want to make is, we want to do things like, if we see that it's getting close to reaching that, and we're not expecting it to because it's a rarely used service, we want to be able to raise an alert. We want to be able to say, at some predetermined threshold, hey, look, this is getting close to the limit. Something might be happening here. We need a human being to come and take a look at this and make a business decision. This isn't a technical decision. This is a business decision. Should we be supporting this? Should we quickly be calling the generic SaaS provider and negotiating? Okay, well, we're going to have a big rush because it turns out that we've just been posted on, tech news dot whatever, and we're going to have a big rush. We want to be able to serve an awful lot of traffic over the next 24, 48 hours, and then we'll see where we go from there, rather than suddenly being charged at full rate. So that's what we talk about when we're talking about protection. I'll pass it back over to you, Chris.
Thank you, Simon. That's the right button. Right. So the last topic we're going to cover in this is I'm calling simplified migration. And I don't think it's a great title, but I'm still trying to come up with the best title for this. But here's the scenario. You have a series of enterprise applications calling a generic SaaS service. I think you've gathered that's a fairly standard scenario from everything we've covered today. For reasons that we may not understand, there is a push to move to generic SaaS version 2. Now, this may be version 2 of the first SaaS service. This may be a completely different SaaS service that provides a similar capability, and we have made the decision to move our business to be based off this one instead of the first one for whatever technical reasons, accounting reasons, cost reasons. The reasons are almost immaterial for this. The scenario is we have to do this. But maybe the enterprise application one who's using this doesn't have any owners, doesn't have an experienced developers associated to it because it's been running for 3 years. And their options are that we don't really want to, they may not sort of be in a position to make the changes, and so they could block the decommissioning of the generic SaaS service. And we all probably have experience seeing this, where we bring a new system online, but the old system is still there for another 10 years. And at some point you get as we said before, a proliferation of downstream services that all do a similar job because the intention has been to move from one to the next. But the reality of it is it's just not been possible because the teams who are using it don't have the capability to make those changes. So what we could do is we could take that generic SaaS v2 and expose it with the same interface as v1. So this requires the API platform team to take the interface that's currently used for generic SaaS and allow it and modify and make a mapping to be able to call generic SaaS v2. This won't work in every use case where there are significant changes that we're going to need additional data coming in. But quite frequently, the additional fields, though will be useful, people can tolerate them not being filled during the transition point. Maybe we can hard code some fields because of the data. Maybe we have to do some additional lookups, but that can be contained inside of the API. And then if we expose this, so the aim is the API that's going to call generic SaaS v2 will have the same interface as generic SaaS, meaning the interface change doesn't have to happen in the enterprise application one. What's more is, at least with IBM API Connect, we can expose it on the same endpoint. And we can use IBM API Connect's facility here to the platform with informing the enterprise application team can migrate their API so it can then start calling the generic SaaS v2. So theoretically here, Enterprise Application 1, all they've had to do is some testing work to validate they're getting the responses and requests they need. But because we should always test everything, but the bulk of the work for this migration has been done in the API platform. Now, if you scale this out to 50 or 60 applications, traditionally, each application would have to go and make that change. By following it in this way, this change is going through this interface layer in the API platform. The API platform team basically have another product they're selling here. They're having this capability to allow people to not have to make changes and allow them to still make use of new downstream facilities. And then, best of all, you can then decommission the old one. And the term here is decommission because we may not turn it off straight away. We may disable it initially in case we have to roll back because we found some unusual edge cases we weren't expecting. But the key thing here is now all of the enterprise applications that have gone through this are now going to be going to generic SaaS v2. And then when generic SaaS v2 could also have an API alongside it for generic SaaS v2 that does not change the interface. But this will allow them then to, pardon me, it'll allow them to have both the old interface and the new interface called in the same system. So this is what we've covered in today's session. Treating external APIs of SaaS providers and AI systems as internal products has many advantages. We've gone through the control and security. We've gone through accountability, and so allowing us to track, understand, and if necessary, internally build. We have gone through protection and rate limiting, so someone can't accidentally make too many calls. A great scenario for this, and I apologize, I meant to say at the end of the session, was there are cases out there where people have accidentally performance tested against SaaS providers and used up all of their funding. It's human error. Human error is the biggest challenge we have in anything. And a solution like this in place would be able to catch that and limit that. And finally, we make it easier to migrate between different SaaS providers. And the key word here is easier. I would never say it is easy, because especially if you're moving from one SaaS provider to another SaaS provider, that interface mapping is going to be subjective and hard. But if we make it consistent across the entire enterprise, it means everyone has the same experiences and everyone will be solving this in a similar way. And if there is no need for the additional new capabilities of it and they just want to continue working as they were, this means we can not stress the enterprise application teams more than we have to. But the other things that we haven't covered in today's session, reducing bandwidth. We said this briefly in the video, but we can add a caching layer where it makes sense into the APIs. We can allow so that if you're say doing lookups, or say you're pulling down weather information, you don't need to do that every second. You could put a 2-hour cache in there, dramatically reducing the number of calls you're making. And this then has the ability that we are saving money because we're having less calls and potentially using less of the consumption cost of calling that SaaS provider. We can predict future usage. And again, we mentioned this briefly with accountability, but when you have all your external applications and you're tracking everything they need downstream, you have the data here. And this data can be used to help understand and predict where we're going. And if you say you have a new application coming on board and you look at them and you have a similar pattern to an existing application, you can more accurately predict what that's going to be. Are you going to need to have additional funding? Are you going to need to grow the contracts with your SaaS providers? And finally, you can build on this ecosystem of users. Because you, as the API platform providers, you will have knowledge of some of these APIs, and you can link the different teams that are using them together. So if a new team comes in and says, I now need to go and use this obscure SaaS provider here, the platform team might say, we're already using it. we've already got another team using it. Go and talk to them. They can give you some advice. This is how you register. This is how you onboard. This is the documentation we have available to you. Go and talk to this other team, and they can give you the lessons they have learned and maybe assist in other ways. And so it's making everyone more into an ecosystem, more self-sufficient inside the organization. So that's what we have for today. Thank you everyone for listening. Here's Simon and my contact details. I believe, Brian, do we have any questions that are coming through?
There's one question. It says, I can really see how this can be used, but are there any differences that we should consider between exposing a SaaS as an API inside the business versus any other API?
That's a great. Are you happy for me to take that, Simon?
Yeah, go ahead. Absolutely.
Sure. So this is a great question. Often I've come to these sessions and talk about the quality of APIs and how every API should have documentation, every API should be secured, every API should have what is needed to make it work and be as self-sufficient so developers can start consuming it as quickly as possible. In my opinion, this is no different. We should be following the same style guidance. The same objective is to make your internal engineers use these as easily as possible. We may be sort of mirroring the interface from Salesforce, but if nothing else, maybe we should have a link there to say, and this is where the Salesforce documentation is. And the same philosophy and the approach should be put in place here. Thank you, Ryan.
Yeah, absolutely agreed. Your external services are basically being delegated to the API platform in this instance. So the relationship we're handling, but it's just the same as if they're calling those external services directly. And that's important when it comes to things like client libraries as well, Chris. So, you know, that's anyway, great question.
Okay, fabulous.
Thank you.
Anyone else want to throw in a quick question? While you're thinking about that, please do remember to take the poll, the survey. You see it in the bottom left corner of your screen. We really appreciate that feedback so we can improve sessions and TechCon in general for next year. And again, we don't have a question right now, but you think of it in the next couple minutes, join our office hours, or maybe you have questions left over from an earlier session in our track. So join office hours, which start at 2:30 and 2:30 Eastern. So right after we wrap this, we'll be starting that session up, and our speakers will be there live, so you can just talk to them directly, ask questions, bring up a topic of discussion that has been bugging you all day or for a while, and let's keep the conversation going. All right, so a couple comments, good session, and but no more questions. So please do fill out that survey for us. Again, we absolutely value that feedback. We need it to keep doing this year after year. So we hope to see you in office hours, and we'll call this a wrap. Thank you, Chris and Simon. Great session.
Thank you very much.
Thank you.